Hey folks, in this video we are discussing the trig ratios and the Cartesian plane. They are there in the Cartesian plane, eh? And so I'm going to introduce this to you by using a nice animation, and I'd like for you to actually, I just hope you enjoy this actually. So just a few things to take note of. I'm using here what we call the unit circle, okay? This is a unit circle because the radius is 1. Now, watch what's going to happen. If I move this here, okay, you can see the radius is 1. Why? Here, on this side here, I have x, okay? This side here, I have y. Now, you see this block here which says values, actually tells us the x value and the y value on each point of the circle. Remember, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. Okay? Now, down here, I have the graph of each function that I would have selected. In this case, I've selected the cosine. So this is how the graph of the cosine looks like. Down here are the values of theta, where theta actually is in degrees, okay? Is in degrees. And as a matter of fact, the value here is 90, the value here is 180, the value here is 270, and the value here is 360. Here we have minus 90, here we have minus 180, here we have minus 270, here we have minus 360. At the top here we have got a 1, at the bottom here we have got a -1, which actually is very important because it tells us, this graph here tells us that the cosine function is actually bound between 1 and -1. And you'll see the same resemblance in the unit circle. Just a few pointers to note. If I were to drag my line here, the red dot down, 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 down there, I want my angle to be 0 degrees. Okay, 0.50, there it is. You can see, here it is, my angle here is 0 degrees. So I'm gonna write 0 degrees here. And I'm gonna write 90 degrees right here, meaning at that point, and 180 degrees here, and 270 here, and finally 360 that side. You will see why I do this in relation to the graph. Now, let us try and some animation here and see the link between the Cartesian plane and the graphs of each trigonometric ratio. Starting now, I'm gonna move and maybe to at an angle of 30 degrees. Let me move at an angle of 30 degrees. And by the way, the angle 30 degrees is what we call a special angle, okay? It's a special angle. If I'm clicking here, you see where my cursor is. If I say special angles, you can see right there, 30 degrees is one of those. And actually, cos of 30 is square root of 3 over 2. I'll record a separate video on how you can figure out the special angles. But again, if you don't mind, enjoy this with me and see how that goes, okay? So we can see the value of x at this point. In other words, this x value here is actually square root of 3 over 2 in Z form. If you don't want it in Z form, is 0.866 in decimal form. And the value of y at this point is actually 1 over 2, or you can say a half. And so when the radius, as I said, this is a what? Unit circle, yes. The radius here is equal to 1. Now, the interesting thing is that if I look at this and I take it as a right angle triangle, okay? And that this angle here is obviously my theta, which is 30 in this case, and I look for cos. Cosine, we said it's adjacent over what? Hypotenuse. Hypotenuse is 1. So that means actually the value of, or the ratio rather, the ratio which is cos of theta is just going to be the x value in the case of cos. When I move to the case of sine, let me put in sine here, then you can see, just look at the green arrow, the ratio is just the value of y, because the value of y here is 1 over 2, okay? The value of y here is 1 over 2, and check this, sine, which is opposite over hypotenuse, opposite is what? 1, hypotenuse is what? Excuse me, opposite is 1 over 2, which is the value of y, okay, meaning the distance from this to that is half, and then what is hypotenuse is 1, and half divided by 1 is just half, okay? So that's another thing. The same thing will happen with the tangent. This is how the tangent graph looks like, and this is how the sine graph looks like. I'm not really going to talk a lot about graphs because I'll do that in a separate series where I explain them nicely. Here, it's just a courtesy, what I call advanced organized learning, where you are actually being introduced to these things, but casually, it will make sense later on when we move along. And when we discuss graphs, absolutely, I will be using the same animation, but now focusing on graphs. At this point, I want you to take note of few important things. When we measure positive angles on the Cartesian plane, we do that in an anti-clockwise direction. That is the very first important note that you must take. In an anti-clockwise direction, we are measuring positive angles. And if we are to go in a clockwise direction, we are measuring negative angles. And I will illustrate this by moving the cursor. You can see the value of the angle increases positively. You can see that as we move along, still positive, still positive. But if I were to come back and I move along here the axis, you see that the value now is negative. In this case, I have negative 30. In that case, I have negative 45 because I've selected special angles. Maybe I should deselect that so that you can see clearly even the decimals. And you can even see how the graph is moving down here. It has moved on the negative x values. So all negative angles will be measured in a clockwise direction, and all positive angles will be measured in an anti-clockwise direction. That is a very, very important thing to note as we discuss this concept of trigonometry in the Cartesian plane, or trig ratios in the Cartesian plane. All right, so that you can just calm down, catch your breath, and get your mind back together. I'll stop here, and in the next video, I will now have each of the trigonometric ratios in the triangle, which is on a Cartesian plane. I thought I should just start with this cool animation to get you geared up and excited, I hope. Cheers.